Okay, so what we discussed in last class was that uncertainty is basically this discrepancy that can arise in a particular reading. Whenever you take readings in practical experiments, there's always a chance of these discrepancies arising. Why? Because of different errors that can occur. What were the two major types of errors that we studied?
Random error and systematic error.
And systematic errors, absolutely. Random errors were caused by observers, and these errors could just be reduced, and you cannot sort of eliminate random errors. Systematic errors, on the other hand, are caused by instrumental faults or zero correction, zero errors, and these errors can be eliminated properly by replacing those faulted instruments. These are basically errors, and these errors, the consequence of these errors is basically the uncertainty that arises between readings. Okay. So there's this thing called absolute uncertainty. Absolute uncertainty is this absolute value that can be, uh, for example, if you look at this, 84.5 plus minus 0.2 seconds. Now, the 0.2 seconds is basically your absolute uncertainty, and it can be written as it is. ठीक है? So this is what absolute uncertainty is, a value that is written alongside the error. ठीक है? जो भी आपका error होता है, जो reading होती है उसके साथ आप value लिखते हो, तो this is called the absolute uncertainty. Got it?
Okay.
Then
Yes.
there's this thing called percentage uncertainty. Now, percentage uncertainty is calculated through this formula, which is absolute uncertainty over the reading into 100. In this case, if your absolute uncertainty was 0.2 and your reading was 84.5, so you're going to do 0.2 over 84.5 times 100, and this will give you a value for percentage uncertainty. Got it?
ठीक है.
जैसे यहाँ पे किया है 0.2 over 84.5 times 100 is 0.24%. We talked about these three different styles of writing uncertainties in yesterday's class as well, if you remember. Um, uncertainty could be written as a percentage as well. For example, if let's say we write 84.5 plus minus 0.24%. Now, this 84.5 plus minus 0.24% or 84 plus minus 0.2 एक ही बात है ठीक है because this is also a form of writing uncertainty and this is another form of writing uncertainties. This one over here is when you write uncertainty as a percentage, and this one is where you write uncertainty as an absolute value. And then there was another one which is uncertainty as a fractional value. अगर यहाँ पे for example if it was 84.5 अब I'm 24 over 10 ही बनेगा ना वो, so it will be 12 over 5, 24 over 10, no, over 100 होगा. Yeah, it's gonna be 12 upon 50, कुछ इस तरह की चीज बनेगी. Up now, this also corresponds to the same percentage. So the fraction again represents the same amount of error. And you can write fraction in place of the error as well. Got it?
Okay.
Okay. Precision of a measurement. Now, this part is a little important. When making a static measurement, for example, the length of a pendulum, you should normally measure to the nearest division on the instrument. यानी जो हम nearest division का मतलब ये है ना कि अगर आपकी let's say smallest division is like up to 1 का gap है, तो you should take your nearest. अब ये ना हो कि आप 1 का gap है आप 0.5 की कोई measurement ले रहे हो, 1 2 है आप 2.5 ले रहे हो, नहीं, you will have to pick up the nearest whole value on that particular instrument, and this would vary depending upon the type of instrument you're using. ठीक है? अच्छा.
ठीक.
अब
Okay.
many digital stopwatches measure to 1/100th of a second. However, the uncertainties in the reaction times of manually starting and stopping a stopwatch are much greater than this. The best you can manage is to measure to the nearest 1/10th of a second. यानी जो digital stopwatches हैं, they can measure up to 100 यानी 0.01 second तक भी they can give you answers. But uncertainties, they're more greater because देखो reaction time है ना आप when you switch on and off a stopwatch, 1 seconds they change so quickly that you there is a very high chance that when you're stopping a stopwatch, you might like skip 1 or 2 seconds. अब 1 second में और 0.01 second में there's a huge gap. So what they're saying is that the actual chance of error in such an instrument is a lot more, is a lot greater than the uncertainty that it shows. तो इसका मतलब ये है कि अगर आप एक भी सेकंड आगे जाते हो, for example 1 to 2, the gap between 1 and 2 second is 1 of 1 second. Now अब 1 second का मतलब ये उसके दरम्यान imagine कितने मिली सेकेंड्स गुजर चुके होंगे. The uncertainty would be very high. Got it?
Yes.
Here, the one way to reduce this or to manage this is to use a stopwatch that has a value of till like 1/10 of a second, right? वो आपको इसके इस तरह की कोई वैल्यू दे रहे हो, तो you should use that. ताकि why should you use that? So your error is less. Because otherwise, for 100, imagine how many 0.01 seconds would be there in like 1 second. So many, right? So this is what they're trying to say. Okay, this could be how you can manage when there are like very high uncertainties.
ठीक है.
Okay, now this is just to test your self question. Vernier calipers, we've done Vernier calipers in yesterday's class in detail. Up thoda sa beginner transition to equations of motion in kinematics. So there's one more thing that is about, again, about uncertainties. So this particular topic deals with addition and subtraction and division and multiplication of uncertainties. I'm not going to teach you that right now because the book or the notes, they don't really go into the detail that I want to take you in. So I'm going to like deliver a separate lecture based on that. And that lecture is going to be from my own notes. Okay? So we're just keeping that on hold. Absolute percentage uncertainty that we're done. There's one more topic again, addition, subtraction, multiplication, division, जो उसमें सब कुछ cover हो जाता है. So we're just keeping that
Of
particular lecture.
uncertainties.
Yes, I'll just keep that on
Okay.
hold, ठीक है, क्योंकि वो मैं आपको अपने lectures खुद पढ़ाना चाह रहा हूँ. तो अभी हम we're gonna transition to kinematics and forces equations of motion. Okay. So now, when we talk about equations of motion, it is important for us to understand these terms such as distance, displacement, speed, velocity, and acceleration. Ragda, can you tell me what is the difference between distance and displacement?
One of them is a vector quantity and the other is a scalar quantity.
Which one is the vector quantity?
Okay. The vector quantity is displacement and the scalar
This
quantity is distance.
correct. Similarly, velocity is a vector and speed is a scalar. Now, what are vectors and scalars? Vectors and scalars are basically uh, different types of quantities. In a vector quantity, there's always a direction. In a scalar, there is no direction. Let me take you back to this topic that is taught in the very beginning when you start your A levels. जिसमें अच्छा अभी because we've started discussion on vectors and scalars, it's best that we cover this as of now. Vectors and scalars में ही ये यहाँ पे scalars and vectors in detail. Scalar quantity, magnitude only. A vector quantity has magnitude and direction. Magnitude is basically the size of that quantity, right? Now, scalar quantity में examples क्या है? Mass, volume, energy. Now, all of these quantities, they don't need a direction. They're directionless. Energy doesn't need a direction to flow, right? Mass, it doesn't act anywhere. However, weight does. So weight is an example of force. Air is a vector quantity. Forces are a vector quantity. Velocity is a vector quantity. Acceleration is a vector quantity, right? So this is the major difference between scalars and vectors. Okay. When scalars are added, the total is simply the arithmetic total. For example, if there are two masses, 2.4 kg, 5.2 kg, the total is 7.6. You just add them. Scalars की addition तो बहुत आसान होती है. Simple addition. But vector addition is a little complicated. When we talk about vector addition, there are two major methods that we follow. Parallelogram method and a head-to-tail rule. ठीक है? I hope you are aware of these terminologies. A head-to-tail rule and a parallelogram method. ठीक है? So these are basically two major um, vector addition procedures that we follow. Okay? अब vectors होते क्या हैं? Briefly, to understand what vectors are, you need to know कि any line, for example, this is a line, and this line represents a force. Okay? Okay, तो बहुत ज़्यादा देखोगे. Yeah. This over here is another line. This over here is another line. Any line that represents a particular vector quantity, majorly हम forces के लिए use कर रहे होते हैं, is a vector. Okay. For example, if I
Okay.
tell you, you must have seen these diagrams a lot in physics. There's like a block of mass, and then there's like a force of 5 Newton acting on that box. Now, this force of 5 Newton is a vector quantity, and this line is basically vector of this force. For example, a force acts on this side, and this is basically 4 Newtons. Now, this 4 Newtons is what? It is another vector. If you remove this box and if you want, let's say, we're asked to just represent this entire vector diagram as it is, you could simply draw these lines like this, 4 and 5 Newton. And you could say, okay, 5 Newton is a vector that acts on this side, and 4 Newton is a vector that acts on this side. Sorry, इसको 4, okay? So this is how you can represent vectors just through these lines. You don't need proper detailed diagrams to represent vectors. Okay. And vectors can be added, subtracted. अब vectors की addition subtraction किस तरह से होती है? अगर तो vectors are acting in a straight line. Number one, जैसे अगर यहाँ 5 Newton है, if I add like a 3 Newton vector over here. So because both of these are acting in opposite directions, you will simply subtract 5 minus 3. Answer will be 2 Newton. 2 Newton will be your resultant vector. If let's say both of them were acting in the same direction, 5 and 3, so the resultant vector would have been 5 plus 3, जिसका आंसर होना था 8 Newton, right? So
Yes.
this is what resultant vectors are, and this is how vectors are added and subtracted. Okay. So, okay. अब हम आते हैं constructing a vector diagram. So in a vector diagram, each vector is represented by a line. The magnitude of the vector is represented by the length of the line and its direction by the direction of the line. Direction line कैसे मिलता है? Angle से मिलता है. For example, this is one line, this is another line, and there's an angle of let's say 60 degrees in between. Now you can say कि अगर if there's like an angle of 60 degrees, so this vector A is 60 degrees north of B. Example, अगर यहाँ पे north है, तो आपने you need to sort of provide a reference to explain the directionality of that vector as well. Okay. So now, over here, how you're gonna draw a vector diagram? Number one, choose a suitable scale because we've studied that each length represents the magnitude of that vector. You will have to pick up a scale. How do you pick up a scale? That, for example, if let's say I tell you that your force is 10 Newton, and then you say, okay, if the force is 10 Newton, I will draw a line of 5 centimeter on paper. Now, this line of 5 centimeters should represent 10 Newton. ठीक है, अब how would this represent 10 newtons? You'll sort of derive a scale. If 5 centimeter is 10 Newton, this means that 1 centimeter is representing 2 newtons, right? So you've sort of made a scale for yourself. So
Yes.
5 would
Okay.
automatically represent 10 newtons. The first important thing is to selecting a suitable scale. ये बात समझ आई?
Yes.
And then, because in question, you're always specified with how to draw the vectors. For example, they will tell you, okay, there's a vector that is acting on the right-hand side and the force is 30 Newton. Okay, then there's another vector that's acting like this. There's an angle in between these two vectors. The next vector has a magnitude of 10 Newtons. So just by looking at this, you're going to come up with the scale and you're going to start drawing those lines with proper angles. Once you draw these two lines, what's important here is that the first vector, the head of the first vector must join with the tail of the second vector. This is important. Head of the first vector with the tail of the second vector. For example, vector तो कहीं पे बना सकते हो, यहाँ बना हुआ है, vector यहाँ बना हुआ है. You're gonna pick it up and you're gonna place it like this. That the joinery should be head to tail. यहाँ तक, is it clear?
Yes.
Okay. And when the joinery is head to tail, your resultant vector would start from the tail of the first vector and go till the head of the second vector like this. This is your resultant vector, starting from the tail of the first and the head of the second. So they meet head to head. But what's the identification of this ordered triangle diagram? It is that there has to be a connection which is head to tail. So automatically your resultant would start from the tail of the first and will join to the head of the second. And now if you try to understand this as a vector concept, as its application, assuming there was this one vector that was acting on this side, कि अब अगर ये assume करते हैं कि for example there's a kite, okay? Now kite पे there was one force that was acting on this side, there was another force acting on this side. Where will the kite actually go? It's going to go like this, right? It will follow the resultant pathway. So this is what a resultant tells you. The resultant direction. When let's say there are two forces being applied, when there are two velocities taking happening in these two directions, so you will know that your resultant will guide you in which direction your object will actually move. So this is why when it comes to directions, angles are very important. Angles help you understand exact position of vectors. Is this clear?
Yes.
अब जैसे यहाँ पे, here's a worked example. You're going to be doing this on your own right now, but let me just explain this first. An airplane is flying with a velocity relative to the air of 200 kilometers per hour. Now, air's velocity is acting in this direction, up north. There is a wind blowing from direction of 30 degrees north of west at 80 kilometers per hour. North of west का मतलब ये कि यहाँ से यहाँ आ रही है. This. And the vector is 80 kilometers per hour. Calculate the velocity of the aircraft relative to the ground. Now you need to figure out velocity of aircraft कैसे निकलेगी resultant. Okay, where will this aircraft actually go? Just by using common sense, you can tell that if one vector is acting in this direction and the other is acting in this direction, and this is an aircraft, so aircraft would move like this. It would gradually deviate towards this side, but it would continue moving in this direction. So automatically, you see, this is how the resultant should be. But what you do here is you draw your vectors. 80 kilometers का vector हमने draw कर लिया, and then 200 kilometers. Now, because the vectors need to join head to tail, so automatically you place your other vector like this. ये head to tail join हो जाए. And once they do, you're gonna draw a line from the tail of the first to the head of the second, and this is gonna be your resultant vector. Now remember that these drawings, 80 kilometers per hour, 200 kilometers per hour, all of it needs to be on a proper scale. And the scale is what you decide when you make your own drawing. Is this clear?
How do you know कि first vector कौन सा होगा, second vector कौन सा होगा,
वो
and
कोई भी हाँ, वो आप कोई भी रख लें, वो तो मसला नहीं है. अगर लेट्स से हम यहाँ पे 200 वाला पहला रख
okay,
लेते हैं, हमने पहली लाइन ये लगा ली. आप ज्वाइन करना है इसको, ये आपको समझ आ गया कि ऐसे ही बनेगा. देखो, ये आप क्वेश्चन में उन्होंने ये नहीं बताया होगा, ये आपने खुद फिगर आउट करना है कि दूसरा वेक्टर की डायरेक्शन क्या होगी. कहाँ से?
okay,
यहाँ में उन्होंने ये बताया हुआ है, ड्यू ये जो 30 डिग्रीज नॉर्थ ऑफ वेस्ट, यानी वेस्ट साइड के नॉर्थ से विंड ब्लो कर रही है. ठीक है, ठीक है.
ठीक.
अब इसका यानी टेल यहां पर है, इसका हेड यहां पर है, तो ऑटोमेटिकली आपको कि इसको मैंने हेड टू टेल केस कर दिया. ठीक है. तो फिर जो आपका
ठीक
अगला
है.
वेक्टर है वो यूं ही बनेगा. So these are some decisions that you will be taking. So now what I want you to do here is, um, I'm giving you some time. You can take a screenshot of this entire question, so you know what to do. Select a suitable scale. Take a scale, a ruler, a pen, a pencil, and draw this vector diagram. And then use your scale to measure this resultant as well, and tell me the magnitude of resultant that you get. Okay? क्योंकि जब आप when you measure the resultant, the answer will be accurate because everything would be drawn on scale. Okay?
Okay.